Let's talk about balanced and unbalanced for a second. Balanced and unbalanced signals, for example. Okay, so when you've got a cable, and you know what? Maybe next time I'll bring some cables, all different types. As you notice, there's different types of cables for different kinds of purposes. Some are balanced cables, some are unbalanced cables. So let's draw a guitar cable, since I like to draw. Right? So you've got a cable here, right? So you've got the center conductor connected in the cable, and then here is what's called a shield, and that's connected to the barrel of the 1/4 inch cable. Okay? That's like a guitar cable. 1/4 inch on one end, 1/4 inch on the other end, a shield around a center conductor. Now, the reason that it's important to have a shield is because floating in the air every day is all of this stuff, this radio waves and electromagnetic fields, sunspots, creating all sorts of fields. And this noise hits the shield, and then it goes through the shield, and it runs off generally. Once this is plugged in, it goes to a ground, and it doesn't create noise. So it shields the inner conductor from the extraneous noise on the outside. The issue is, though, when this is plugged in, your amplifier, your guitar amplifier, will use plus voltage there, minus voltage from the barrel. So you've got your signal, your potential difference. That's great, and it works really good. Unfortunately, the shield is also used for the low side of the signal, and it's also used to capture all the extra noise. So if the cable's short enough, it works very efficiently and very well, and it doesn't have a lot of extra noise. But when you start running these long lengths of cables, it picks up so much noise that it starts infiltrating the signal that you're trying to actually send through the cable. And so there must be a better way to do this, where you can actually shield the cable for long distances and also carry the signal that you're trying to carry. Let's draw a balanced cable. That means that there's actually a cable, and there's two conductors on the inside. One is plus and one is minus. So here's your signal traveling on the two inner conductors, and it's protected by a shield that just acts as a shield. So any noise that gets to the shield runs off the ground and doesn't affect the inner two conductors that carry your signal, right? So it's great for long distances. So let's say you're doing a remote truck at a concert hall and you're recording it and you have to run 500 feet cable. This is how you do it. Short runs, like from my guitar to my amp standing right next to it, pretty much, or up to 20 feet or so, 25 feet, is an unbalanced cable. Works great. Usually unbalanced cable is usually for high impedance. Balanced cables are usually for low impedance. Different connectors too, because you've got this is a microphone cable, right? Where you've got the connector with the 3 pins, plugs into your microphone and plugs into your mic preamp. This is just a 1/4 inch cable that plugs into a round receiver on your guitar amp or on your guitar. And I've got a picture here of balanced and unbalanced for you. The interesting thing about it is that you can have a 1/4 inch cable that's actually balanced as well. How you do that is you take what's called a stereo 1/4 inch plug, and actually my little patch cords in the studio to patch from one to the next are all balanced, and they call them ring tip sleeve, a connector that looks like this. And in here, obviously, is an insulation. You've got an insulation here and here. So you've got ring, tip, sleeve on 1/4 inch connector. So you can carry the 2 ring and tip, your 2 cables, and your ground is on your sleeve. Right? That's a stereo 1/4 inch. So they come in all different varieties. The thing that really distinguishes them is that the unbalanced has 1 inner conductor and a shield. The balanced has 2 inner conductors and a shield. And they're used to protect yourself better from noise getting into your signal. In general, your guitar is made for an unbalanced cable, and your guitar amp's made to receive an unbalanced cable because they expect you're standing close to your amp. If you'd like to convert it with direct boxes to a low impedance 3-prong, plug your, let's say your bass, plug it into a DI. On the other end, you get a 3-prong mic cable coming out, right? You plug your mic cable into that. You can run it hundreds of feet, and on the other end, put it into a direct box and get high impedance coming out, unbalanced 1/4 inch out of that box in reverse. You can run long distances that way too, because the low impedance and the extra shield protects it for long distances. So that said, you can adapt MIDI that way too. Does anybody use MIDI? signals, or you can use MIDI in the same fashion. You can adapt a MIDI connector into a mic cable and run it long distances and then convert it back to a MIDI connector. And I did that years ago when I put together a Madonna tour. She had moving stages and MIDI running off stage from computers, and so I had to think of creative ways of making cables long enough. And during the first rehearsal, one of the stages moved over my 200-foot MIDI cable and just cut it in half. So I was thinking, well, if that happens at a show, what can I do? They've got and the whole stage was cut off from all of the sample sounds that we were using. So what we ended up coming up with is that with a sound company, they've got millions of mic cables everywhere, and they're easy to snap together and make longer. So I figured if I adapt my MIDI to become a mic cable, then I'll always be able to repair it real quick and maybe just miss half the song or something. So we did that. We converted every cable into a mic cable because there were hundreds of mic cables around, and they were durable and they were low noise. You can come up with all those creative tricks too. Impedance we talked about, and that's really important to how signals transfer from one piece to the next. You need to remember that it's frequency dependent, it's measured in ohms, and there's always a confusion between what impedance is and what resistance is. Resistance is non-frequency dependent. Impedance is frequency dependent. Voltage dividers, if you have a string of resistors all at different sizes, you can divide the voltage into different segments. Impedance matching, we just talked about how to get the best signal-to-noise ratio and the best signal transfer. There it is, 10 times rule. There it is, right there for everyone to see. Okay, balanced and unbalanced one more time. Balanced versus unbalanced signals. Balanced system is the difference between two conductors on the inside of the cable. Unbalanced has one conductor on the inside of the cable and uses the shield as the other side of the signal. Now, as promised, but we're going to talk about grounding and why that's so important. Every third pin on every plug, power cable to your computer has a third pin. They make those little lifters, and a lot of people I see with guitar amps with lifters on them because it makes it quieter. Well, it makes it quieter because there's two different grounds going on, and when you lift one of them, then all of a sudden the noise goes away. And I'll get into more about ground loops, which is actually what we're talking about. A ground loop is where you've got two different competing grounds, and the noise that hits the cable is actually moving in a circular path and reinforcing itself and creating noise in your system.